Hi there, this is Guided Practice 16. We're talking about 4.6 and 4.7, looking at the derivatives of exponential and logarithmic functions. And these are our practice problems. So let's jump right in here. Remember that the two things that we know about exponentials and logs is that the derivative of e to the x is e to the x. It's itself. The derivative of ln x is 1 over x. And then if this comes up, we don't use these very often, but if you have a to the x, that's a to the x times the natural log of a. Okay, so let's jump right in. Now, the nice thing about natural logs, some of you may not be as comfortable with them because they're less familiar, but they have some really nice properties. So the other thing I want you to remember, and I think we talked about these at the beginning of the semester, but I want you to remember that the natural log of a times b, right, is equal to the natural log of a plus the natural log of b. The natural log of a divided by b is the natural log of a minus the natural log of b. And the natural log of a to some power, you can bring that power down in front. Now, a couple of things here. Why are these nice? Well, they take something that's multiplication or division, which we have to use a rule for, into something that's addition or subtraction. So it actually can simplify things pretty significantly for you. So if you have ln's, think about trying to simplify first. The other thing is that I don't want you to mix up this rule with taking the derivative, right? So take note here. In this case, we're bringing down the exponent and multiplying by it because this is a natural log, not because we're taking the derivative, okay? So be careful about that. Know which one you're doing. Are you taking the derivative or are you simplifying a natural log? Okay, so then let's take a look at this. Some other things. Oh, I didn't mention this. Remember that natural log and e are inverse functions. So the natural log of e to the x is just x, and e to the natural log of x is also just x. They kind of cancel each other out. So when we see this one, we have two options. Option one is to simplify first. And really, this just turns out to be x, so that means that the derivative is just 1. Okay, now if you didn't see that, then this is actually a chain rule because you have the ln of x on the outside and the e to the x on the inside. And so the way that we handle that is just like we would handle anything else. Now, keep in mind, the derivative of ln x, when I have the ln of x, I get 1 over that x. If I change that x, I'm going to get 1 over whatever's there, okay? So when I look at the derivative of ln here, the derivative of ln is 1 over whatever's in the parentheses. In this case, it's an e to the x. Then I have to multiply by the derivative of the inside, which is e to the x. And of course, those two cancel out to be just 1. So either way, I'm still getting 1 for number 1. Next, e to the cosine x. Okay, same kind of thing here. This is e to the cosine x. So if I'm putting parentheses, it would go around the cosine, right? That's the argument of the exponential function. The other way you might see exponentials written is this way, exp of something, right? And so that way you can see the function and the argument a little bit better, and it kind of matches up to some of our other special functions. Okay, in either case, your cosine is on the inside, and your e, or your exponential, is on the outside. And so that means we're going to use chain rule here, because I've got an inside and an outside. And we have the derivative is equal to the derivative of the outside. So the derivative of e to the x would be e to the x. So the derivative of e to the cosine has to be e to the cosine, right? So you get back exactly what you had before, times the derivative of what's inside. The derivative of the cosine is negative sine x. Okay. If you want to write that with the negative out front, this is negative e to the cosine x times sine of x. And I'm done. Number 3. Okay, so here's where our rules are going to help. So I'm going to do this 2 different ways. So the first way I'm going to do this is by simplifying first. Okay, so when we simplify this first, we notice that we're taking the natural log of a division, right, of a fraction. So that means that this is equal to, so f of x is equal to the natural log of x squared minus the natural log of 4x minus 1. Okay? And you can see that I got rid of the division. The other thing that you can do here is you can take this square and bring it down here because of the log rules, not derivatives, because of log rules. So I still have f of x because I have not yet taken the derivative. I can bring that 2 out front and make it 2 times the ln of x minus the natural log of 4x minus 1. Okay, now I'm ready to go ahead and take the derivative. So when I take the derivative here, for that first term, the 2 times the natural log of x, I leave the 2. And the derivative of natural log of x is 1 over x. Minus. Okay, now here on this term, we have the natural log on the outside and the 4x minus 1 on the inside. So we want to use chain rule. Our outside function is the natural log. Derivative of natural log is 1 over whatever I have. So 1 over what's in the parentheses, so 4x minus 1, times the derivative of what's inside, which is 4. So this becomes 2 over x minus 4 over 4x minus 1. The 2 4's do not cancel because it's not common in all 3 places. Remember the negative 1 there, the minus 1 is connected to the 4x. So that's my answer. Okay. Option 2, if you didn't see to simplify, would be to think about this as an inside function and an outside function. So the derivative of the natural log is 1 over whatever I have there. So f prime of x is equal to 1 over the x squared over 4x minus 1. Okay, when we take reciprocals, we know what happens to complex fractions. It's going to flip them over, but we'll deal with that in a second. Times the derivative of what's inside, and the derivative of what's inside is a quotient. So let me move this down a little bit. And we'll get our tops and bottoms up here. So the top is x squared, and its derivative is 2x. The bottom is 4x minus 1, and its derivative is 4. So when we put this together, we get top prime bottom, so 2x times 4x minus 1, minus bottom prime top, which is 4x squared, all over the bottom squared, which is 4x minus 1 squared. Okay, when we clean this up, we know that 1 over a complex fraction take the reciprocal. So that means we get 4x minus 1 over x squared times, let's see, that's 8x squared minus 2x minus 4x squared over 4x minus 1 squared. Now, I have a 4x minus 1 on the top and 2 of them on the bottom. So 1 of each will cancel. And we will have, let's see, on top, I have 8x squared minus 4x squared is 4x squared minus 2x. On the bottom, I've got the x squared on the left, and I've got 4x minus 1. And that's my answer. Now, you may be saying, hey, guess what? We got 2 different answers, right? Well, yes and no. These 2 are actually algebraically equivalent, okay? If you were to factor out, notice on the right-hand side on this one, if you factored out an x on the top, you could cancel it with one of the x's on the bottom. So this actually simplifies to 4x minus 2 over x times 4x minus 1. And that, if you took the one in purple on the left and got common denominators, you would end up with exactly what I have on the right in blue. So 2 different ways to approach 2 different correct answers that are algebraically equivalent. All right, number 4. Again, I'll show you 2 different ways, and then after this, I'm going to stick with the simplified way, right? So first thing we're going to do is write this as the natural log of x plus 2 to the 1/2, okay? Now, natural log rules, you've got an exponent here, that can come down in front. So this is actually equal to 1/2 the natural log of x plus 2. That way, when you simplify first, and you take your derivative, you're going to leave the 1/2 out front. The derivative of the natural log is 1 over whatever's there, so x plus 2, times the derivative of what's inside, which is just 1. So this is just 1 over 2 times x plus 2. If you had done it the long way, and that is to not recognize the 1/2, that the 1/2 can come down, from here, you would say, okay, I have 3 functions nested together here. So you're working with f of x equals the natural log of x plus 2 to the 1/2, right? And so really it looks like this. So you have an outside function, an inside function, and a middle function. So what you would do here is you take the net derivative of natural log, because that's the very outside, that's 1 over whatever's there, so x plus 2 to the 1/2, times the derivative of the pink part, so bring down your 1/2, leave the x plus 2 alone, decrease the exponent by 1, and then we multiply by the very inside, the yellow part, so times 1. And so if you notice what happens here, this is 1 over x plus 2 to the 1/2 times 1 over 2x plus 2 to the 1/2. And when you multiply these two together, you add the exponents and you get 1 over 2 times x plus 2. So you do get exactly the same thing, just using a different way. Okay, so you can start to see the power of simplifying your natural logs. All right, number 5, e to the secant x. So there's nothing to simplify here. So we're just going to jump in. We know that the inside function is our exponent and our e is the outside function, right? If you're not sure, it looks like this. And so when you go to take your derivative, you're taking the derivative of the blue part first, of the e. So that's just e to whatever I have, times the derivative of what's inside, so times the derivative of the yellow, and that's secant x, tangent x, and that's my answer here. And lastly, number 6, we have the natural log of tangent cubed. That's the natural log of tangent, oops, let me switch colors back. This is the natural log of tangent x cubed. So again, and I'm not going to do this one the long way because I want you to get used to seeing this, we're going to move that exponent down and rewrite as 3 times the natural log of tangent x. Okay, that way when I go to take my derivative, I leave the 3 out front. The derivative of natural log is 1 over whatever I have, and then the derivative of tangent is secant squared. Now I'm going to go ahead and convert these to sines and cosines. So this is 1 over sine x over cosine x times 1 over cosine squared x. See if anything cancels. So this is 3 times, flip this one over, so that's cosine x over sine x times 1 over cosine squared x. And we can see that one of those cosines is going to cancel. And that's going to leave me with 3 times 1 over sine x times 1 over cosine x. And this is 3 times 1 over sine is cosecant, and 1 over cosine is secant. And that's my final answer. Okay, again, if you miss that simplification, you're going to have 1 over tangent cubed times, bring down your 3 times tangent squared, and then you've got to multiply by the derivative of tangent. So there's a lot more to do and to cancel, okay? But you should get to the same answer.